Good morning, student. Today we are going to learn about pulse code modulation. In short, we can say PCM modulation. After the completion of today's session, you are able to describe the operation of PCM transmitter, discuss about transmission path used in PCM, explain the operation of PCM receiver. So, pulse code modulation or PCM. In PCM, an analog signal is converted into binary sequence, that is ones and zeros. Three elements of PCM is transmitter, transmission path and receiver. The essential operation in the transmitter of a PCM system are sampling, quantizing and encoding. As we know, these three operations are needed for conversion of analog signal to digital, and PCM is a digital modulation. For that, it needs these three steps in its transmitter section. So, sampling is the operation in which an analog signal is sampled according to the sampling theorem, resulting in a discrete time signal. As we know, the sampling theorem is sampling frequency should be greater than equal to twice of maximum frequency of the signal, of the modulating signal. The quantizing and encoding operations are usually performed in the same circuit, which is known as analog to digital converter. The essential operations in the receiver of a PCM system are regeneration of impaired signals and decoding and demodulation of the train of quantized samples. And in transmission path from the transmitter to the receiver, regenerative repeaters are used to reconstruct the transmitted signal. So, these are the main functions of these three elements. Okay. Next is the PCM transmitter. So, this is the theory part. Let's go to the block diagram. So, in PCM transmitter, the signal x of t is first passed through the low pass filter. So, this one is the source of modulating signal, that is x of t. Okay. Then the x of t or modulating signal is given to the low pass filter. So, we can say this one is the first block of PCM transmitter. So, the x of t is first passed through the low pass filter having cutoff frequency FM. So, the low pass filter is having the cutoff frequency, that is FM, frequency of modulating signal. Then this low pass filter blocks all the frequency components which are lying above this frequency of the modulating signal. Only allow this frequency signal. This means the signal x of t is band limited to FM. Then the next one is the sampler. Means here the sampling is done. As we know, for sampling we use sample and hold circuit. So, the sampler is the sample and hold circuit, and the sample and hold circuit samples the signal at a rate of Fs. Why Fs? As we know, the sampling frequency should be greater than equal to twice of the modulating frequency. So, it samples the signal at a rate of sampling frequency. Then at the output of the sample and hold circuit or sampler, we get x of NTS, means the output of the sampler is denoted as X of NTS. This signal X of NTS is discrete in time and continuous in amplitude. Then the signal is applied to the quantizer. As we know, what is the function of quantizer? Quantizer compares the samples with a predefined levels. So here also the quantizer compares the samples with the predefined levels, and which results in minimum error. Okay, then this error is called quantization error. Thus the output of the quantizer is a digital level called XQ of NTS. So input to the quantizer is X of NTS sampled signal, and at the output of the quantizer we get XQ of NTS, a quantized signal. Okay, then the quantized signal is given to the encoder. This encoder converts input signal to digital binary bits. Thus the quantized signal is converted to binary bits. This encoder is also known as digitizer. As it converts the signal to digital value, because of that it is known as digitizer. An oscillator generates the clock signal for sample and hold circuit and parallel to serial converter. This one. Okay, this one is the oscillator, means here the synchronization is provided to these two blocks. Mainly it maintains the sampling rate. Okay, so this is all about the PCM. No, one second. Then the output of the encoder given to the parallel to serial converter. So within the circuit the data are transmitted in a parallel manner, but in a transmission line the data is always transmitted in a serial format. So here parallel to serial converter convert that parallel digit into serial. Okay, then at the output we get our PCM output, and it is given to the transmission path. Okay, so the path between transmitter and receiver in which the signal is transmitted is known as transmission path. Okay, so the most important feature of PCM system lies in its ability to control the effects of distortion and noise. When the PCM wave travels on the channel, PCM accomplishes this by using a chain of repeaters, or we can say regenerative repeater. Such repeaters are placed close enough to each other on the transmission path. Each repeater reproduces the clean noise-free PCM signal from the received distorted PCM signal. So because of that reproduction it is known as regenerative repeater. Okay, and the presence of repeater improve the performance of PCM. Okay, so these are the regenerative repeater. These are spaced close enough to each other to give a better noise free signal at the receiver section. So this one is the internal diagram of regenerative repeater. So first one is the amplifier equalizer. As we know, the amplify the signal. Okay, so this amplifier equalizer reshapes the distorted PCM wave so as to compensate for the effect of amplitude and phase distortion. Okay. Then this timing circuit. The timing circuit produces a periodic pulse train which is derived from the input PCM pulses. This pulse train is then applied to this decision making device. The decision making device uses this pulse train for sampling the equalized PCM pulses. Okay, means this. The decision device makes a decision about whether the equalized PCM wave at its input has 0 value or 1 value at the instant of sampling. Such a decision is made by comparing equalized PCM with a reference signal. At the output of the decision device, we get a clean PCM signal without any noise. So, decision making device compare the output of equalizer and timing circuit. Then as per the comparison it gives the output. Next is the PCM receiver. So this one is the theory part. Let's go to the block diagram. So first block of this PCM receiver is a regenerator, means that is regenerative repeater. As we know the function of repeater, that it gives the noise free clean PCM signal. So at the output we get the clean PCM. Then in the transmission part, the data are transmitted in a serial format. So when it enters to the circuit, the serial to parallel converter again convert the signal from serial to parallel. Then the signal is given to a digital to analog converter, means this block is used to convert the digital signal into a analog signal, means sampled signal. Okay. Then the sampled signal is given to a sample and hold circuit that used to again recover the original signal from that samples. Then the output of the sample and hold circuit is given to the low pass filter whose cutoff frequency is FM, and at the output of the low pass filter we get our original signal, that is x of t, and the synchronization pulse is given to the regenerator, serial to parallel converter and low pass filter. So this is all about PCM, pulse code modulation technique. And application. So the PCM is used in the satellite transmission system, and also it is used in space communication, telephony, and the compact discs is a recent application of PCM. So this is all for today's class. Thank you.